Alright, if we have two given functions, let's call them f and g, we can create four new functions using arithmetic. We could add the functions, we could subtract, multiply, or divide. So this first function, its name, like f has a name, right? Its name is f. This new function, when you add the functions, is called f plus g. And the input to this function would be x. So this is f plus g of x. And its definition is f of x plus g of x. So on the left side, x is the input to this function f plus g, and by definition, x is going to be fed to the function f, x is going to be fed to this function g separately from f, and then the outputs of those two separate functions will be added together to give us the output of the f plus g function. Similarly for the others, so they're all defined exactly as you would expect, and the domains, when you go to find domains of these functions, you have to consider that the input x to the original function is actually input to each of the functions separately, so you have to consider that when finding the domain. Let's look at some examples. So here I've given you two functions, and we're going to first start by finding f plus g of x and its domain. Well, f plus g of x is f of x plus g of x separately. So that's 2 over x plus 2 plus x over x plus 2. And this simplifies down to 2 plus x over x plus 2. And 2 plus x is exactly the same thing as x plus 2. So those reduce each other and become 1's, and 1 divided by 1 is 1. So the output of this function f plus g is simply 1. But any input has to go through this entire process to get down to become 1. For example, if x were negative 2, it would have to go through this first step, second step, and third step. But unfortunately, if x is negative 2, you couldn't plug it in here because you get a 0 in the denominator. So right off the bat, we know negative 2 is not in the domain. So we should investigate the domain here, and when you want to find the domain of these new combined functions, you should always use the first step that shows the combination of the functions that are being used. So we're going to find the domain using this step. Alright, so what we're going to do is we're going to look for any restrictions, and we can see that there's a denominator of x plus 2. So we're going to set x plus 2 equal to 0 and find that we've got a critical value at negative 2. So we're going to cut our number line there. We already know negative 2 is not in the domain. If you plug in numbers less than negative 2 for x, there's no problem in this fraction because you can have negative numbers on the bottom, right? For example, negative 10, if you plug in negative 10 for x, this denominator is negative, this denominator is negative, the top is negative. There's no problems here because in fractions the only problem is you can't divide by 0. So every number in this region is in your domain. And similarly, every number over here is in your domain because if you plug in numbers bigger than negative 2, we still don't get 0 in any denominators. So our domain is this shaded region on the number line. F minus g of x is exactly the same thing, except when you combine these with a common denominator, you cannot reduce this fraction. So this is the output, and we still find the domain in this first step. And we get the exact same result as before, because we still just got fractions and the denominators can't be 0. Alright, fg of x, multiply the two functions, so you just multiply straight across and you get 2x over x plus 2 quantity squared. You cannot reduce this either. We still use this step to find our domain. And once again, it's the same as it has been in the other problems. F over g is a little bit different. This is the same thing as 2 over x plus 2 times the reciprocal of the denominator, so x plus 2 over x. The x plus 2's cancel, and so we just end up with 2 over x as the output of this function. We still find our domain in this step, so we definitely need to cut our number line at negative 2, but also we should cut it at 0 because this x is part of an entire denominator. So you should verify that your domain ends up being everything but negative 2 or 0.